All right, guys, here we go. So we know how to take the derivative of sine x and x squared minus 4. I'm just reading the notes up here. But how do we differentiate a composite like sine of x squared minus 4? Well, the answer is chain rule. So let's chat about what chain rule is. I guess, should I bring out the M&Ms? Not that I have M&Ms, but the M&M example. Sorry if I keep getting your hopes up. Okay, everyone knows what an M&M is, right? So if you had an M&M and we asked you to eat it in a weird way, like we asked you to eat it from the outside in, like not just bite it right off the bat and just break it up. So an M&M has shells, right? You have an outer shell, and then it's a chocolate, and then it's a peanut. So you work your way from outside in. So yeah, see, so that's what you're doing. You're just eating the M&M like weird, like you're working from the outside in. So check it out. So it's example 1. Consider the function 6x minus 10. All right, guys, focus. Which can be rewritten. You can factor out a 2, and you can rewrite this as 2 times 3x minus 5. Now, if you did this as a composite function, you can say that y equals 2u, where u is 3x minus 5. How are the derivatives of these three functions related? Okay, well, let's see, guys. Y equals 6x minus 10. All right, focus, guys, focus. So what's the derivative of 6x minus 10? Just 6, that's it. Yay or nay? All right, now look at this. Y equals 2u. I can take the derivative of this, but this is not taking the derivative with respect to x. This is taking the derivative with respect to. So what's the derivative of 2u with respect? What's the derivative of 2u with respect to u? 2. That's it. So u equals 3x minus 5. And then look at this. I can take the derivative of u, but with respect to x, I'm going to write it as du dx. Du dx is equal to 3. And I'm going to rewrite this y prime as dy dx. So look at this, guys. I want you guys to see that the way to get dy dx is to do, so I'm going to write dy dx equals dy du times du dx. Notice that when I multiply these du's would cancel out, and you'll just have those units of dy dx. Notice that 2 times 3 is also 6. Do you guys notice that, guys? So this dy du is like an outside. Child, what do you mean by outside? Well, look, this 2 is on the outside, and that 3x minus 5 is on the inside. Do you guys see that or no? When I say inside, I mean like it's inside that parentheses. And this du dx is like inside. So that's why you're going to hear me say derivative of the outside, leave the inside alone, times derivative of the inside. You're going to be hearing me say that just like an M&M. Work your way from the outside in. Or how many licks does it take to get to the center of a Tootsie Roll? Yeah. Tootsie Pop, whatever it may be. So outside in. All right. So look at this, guys. Yeah, relax. We're going to go slow. You see this function right here? It's a polynomial. I'm going to write 9x to the 4th plus 6x squared plus 1. I haven't done anything crazy. Everyone in this room knows how to take a derivative of a polynomial. Yes or no? All right. dy dx equals, what's the derivative of 9x to the 4th? Plus, what's the derivative of 6x squared? 12x. Oh, that he found them?
And then you wanted to ask if you're going to dinner tomorrow.
No. That's the Cardinal Center one, right?
Yeah.
No, but thank you for, whoever put the invite out. But yeah. All right. Oh, so yeah, just leave them there. Are we okay so far? Now, hopefully you guys remember that this, in factored form, is 3x squared plus 1 to the square. And relax, maybe we'll do a review one of these days. So I'm going to rewrite it. So this is the same thing as saying 3x squared plus 1 squared. Yes or no? And that we can rewrite it like so. Look. So this, what if I say that u equals 3x squared plus 1? So then I can say y equals u squared. And it's the same thing. It's the same as this. Yes or no? it becomes a composite function. So how are all these related? Well, now look, let's see. So I'm going to change colors. You don't have to change colors if you don't want to. I'm going to take the derivative of y, but with respect to u. So I'm going to write dy du. What's the derivative of y with respect to u? 2u. Child, there's a u in there. Okay, we'll figure it out in a little bit. I'm going to take the derivative of u now. I'm going to write u equals 3x squared plus 1. I'm going to take the derivative of u with respect to what letter? X. So du dx is equal to what? What's the derivative of 3x squared? 6x. All right. So I know what you're thinking. You're like, Chav, last time you said, so here it is. That formula there really is chain rule. dy dx equals dy du times du dx. And you're thinking, Chav, this time it's not going to work because there's a u. Okay, well, relax. dy dx equals dy du was 2u times du dx, which is 6x. What was the letter u, though? So 2 parentheses 3x squared plus 1 times 6x. So I'm going to rewrite it as 6x times 2. That's 12x. 3x squared plus 1. Have I confused anyone? Okay, all I did was 6x times 2, right? Now look at this. What is 12x times 3x squared? What's 12 times 3? 36x to the third. And then 12x times 1? OMG, look at that. 36x cubed. 36x cubed plus 12x. 36x cubed plus 12x. Yay or nay? So in reality, the chain rule really is this. And I'll write it right here. I'll put it in here for good notes. Chain rule really is dy dx equals dy du times du dx. Chav, is there another way to rewrite it? Yes, there is. I'm going to give you that formula right now. So what do we do? Derivative of the outside. We left the inside alone. Times derivative of the inside. And don't worry, we're going to practice. Chav, what do you mean by that? We're going to practice. Oh, should we practice right now? With this? Okay, let's practice with this one. I'm going to change the colors to burnt orange if we have any UT fans here. Y equals... Look, just, you know what? Don't write anything down. Just listen. Don't write anything down. Just listen. So on the outside, I don't have anything other than 1, right? So here's how you do it. You guys ready? Don't write anything down. Just listen. dy dx equals, we take the derivative of the outside. So you see this 2? You bring it down just like power rule. 2, we leave the inside alone. 3x squared plus 1. Close it. We subtract 1 from that power. And now I take the derivative of the inside, 6x. See? And now, look, 6x times 2, that's your 12x. Did I do everything correct? I don't see any mistakes. Times 3x squared plus 1. 12x times 3x squared, there's your 36x cubed. 12x times 1, there's your 12x. Look at that. Cool, right? Don't worry, you don't have to write that down. As long as you observed and you saw how it worked, we're going to have plenty of practice later on anyways. Okay, how do we feel? All right, so here's the chain rule, guys. And I know it says rule 8. We're not counting. We don't have our textbooks. We don't know how many rules we know. So here it is. That is your chain rule, really. So I'm going to write d dx of a composite function f of g, g's on the inside, is equal to the derivative of the outside. Leave the inside alone. Times derivative of the inside. Let me write it better because I feel like it's too crowded. Let me write it better again. I'll write it right here. d dx of a composite function f of g is equal to derivative of the outside, leave the inside alone, times derivative of the inside. And that's what they're trying to tell us. Oh, look, it's right there. This is a composite function, guys. That means f of g of x. Well, it's up there too as well. How do we feel? Nothing crazy, right? All right, check it out. Example 3. An object moves along the x-axis of its position at any time t greater than 0 is given by x of t equals cosine of t squared plus 1. Find the velocity of the object as a function of time. How do I find velocity from position? Oh, I don't know if we even discussed that. No, we have. I find the derivative. The derivative of position is velocity. Remember, guys, the derivative means slope. If you have a position time graph, the instantaneous slope is going to be the speed, the velocity. Does that make sense? Okay, here we go. Velocity, v of t. So what is outside, what is inside? Whenever you have a trig function, the argument is considered inside. Cool? So what's outside? The cosine, and the argument is considered inside. Okay, here we go. Derivative of the outside, what's the derivative of cosine? So I'm going to write negative sine, leave the inside alone, t squared plus 1, plus it's the argument, so you can't touch it anyways. Are we okay? Are we done? No, it's not linear. The argument's not linear, so now I got to take the derivative of the inside. What's the derivative of the inside? Well, even if it wasn't, it would still do the same. Times 2t. We rewrite it. Usually you want to put the 2t in the front. So my v of t is equal to negative 2t sine of t squared plus 1. And that's it. That's the velocity. In terms of t. How do we feel? Nothing crazy, right? All right. And then I put, here's where I distribute M&Ms. Sorry. Rain check. When do you guys want your M&Ms? Oh, man. How about?
By Friday.
Okay, by Friday.
Yeah,
Friday, because no, it's because the next 2 days are going to be a long day because I have a college board meeting tomorrow. It starts at 6 p.m. and it's going to go all the way to 8:30. So. All right, here we go. It sometimes helps to think about the chain rule this way. So here's my composite function. In words, differentiate the outside function of f and evaluate it at the inside function g of x left alone. Then multiply. Okay, so you'll hear me say take the derivative of the outside, leave the inside alone, then take the derivative of the inside. Okay, whatever. So it says to try example 3. Oh, we just did example 3 with chain rule with that, right? Okay, so let's try this one again. No, you know what? I'm just going to make one up. So let's try y equals, let's make one up together. 3 parentheses, what do I want? I want 5x squared plus 7, close it, to the 4th power. Okay. Ready? You could, if you wanted to, expand it out, all of it, and then just use power rule. If you know Pascal's triangle, you can probably expand it out pretty fast. But it's probably better if you just do chain rule. You guys ready? I'm going to go slow. Y prime equals derivative of the outside. So what's the derivative of the outside? 12. Perfect. 4 times 3, which is 12. Leave the inside alone. 5x squared plus 7 raised to what power? To the 3rd. Am I done?
No.
Times derivative of the inside. What's the derivative of the inside? 10x. There it is. That's my derivative. Of course, if you want to simplify it further, you can, but I would just leave it alone. Because right now, all we're doing is just that. Does that make sense? Okay, let's go to the next question. That's it. That's it. Yeah, that's it. All right, it differentiates sine of x squared plus x with respect to x. So here's what I'm going to do, guys. I'm going to give it a letter. So here's my letter. Y equals sine of x squared plus x, close it. And I'm taking the derivative with respect to x. You guys ready? So for trig functions, y prime equals, what's the derivative of sine? Cosine. So write cosine, leave the inside alone. X squared plus x times, what is the derivative of x squared? 2x. What's the derivative of x? 1. Make sure to put parentheses on like that. I would leave it like that. You can't mess with the argument. Don't mess with the argument. The x squared plus x is x squared plus x. Leave it alone. How do we feel? Okay. All right. A 3-link chain. As long as there's still stuff on the inside, you're going to keep going. So look at this one. Chav, what are you talking about? This 10 has an inside, what's the argument, but then notice there's a sign, and that has an inside. Do you guys see that? These are kind of fun. You work your way always from the outside in. Just, I don't know, pretend like you're eating an M&M. All right, here we go. But like you're not crunching it. You're just, yeah, okay. Maybe that's weird. I don't know. All right, here we go. G prime of t. You guys ready? What is the derivative of tan?
Cosecant square.
No, not cosecant. It's not negative. Just secant squared.
Oh.
Secant squared, you got to keep the argument. So secant squared of this expression. 5 minus sine of 2t. Close, close. Are we okay so far? Okay, you're not done with the derivative. You got a chain rule here, a 3-link chain. Now I'm going to take the derivative of that inside. The derivative of 5 is 0. What is the derivative of a sine? Cosine, but I have a negative in the front. So negative cosine, and you got to keep the argument, of 2t. Close, and I guess technically you could close. Well, I'm not going to close it. Times, I still have another inside. What is the derivative of 2t? 2. Close. So g prime of t, let me simplify it here for you, is going to be, let's see, negative, I'm going to write it like this. I'm going to write this one first. Negative 2 cosine of 2t secant squared of 5 minus sine 2t. Close, close. It's all a product. It's all being multiplied. How do we feel? Should we do another one before we go? Yeah, we got plenty of white space. Let's do another one down there. I'm going to change my color. This is a brand new question. I'm going to do f of x equals, let's see, I want to do a triple link. Giant parenthesis. The trig ones are perfect for triple link. Cosine of 5x squared plus 3 close to the 4th. You guys ready? Derivative of the outside, then derivative of the inside, then derivative of that inside. F prime. What's my first derivative? Like, what do I do first? For the 4, leave the inside alone. Cosine of 5x squared plus 3 close to what power? 3 times, yeah, I should have put one more. That's fine, no big deal. What's the derivative of cosine? Negative sine of, you got to put that argument, 5x squared plus 3 close times, what's the derivative of that inside? 10x. And when I say that inside, I'm still talking about this one. It just so happens that that's the same. Close. So my f prime looks like this. What is 10 times 4? 40x. And then you see this cosine that's being cubed? I'm going to put the cubed right here. Cosine of the 3rd power, 5x squared plus 3, close. Sine of 5x squared plus 3. Oh, negative. I don't see any errors. Everything looks good to me. 4 times 10x, and there's a negative right there. It's all a product. Yeah, it's all a product. Something times something times something. This one, don't mess with it on the inside. That's to the power 3. You can't multiply anything to the with the inside, right? Like if I had a 2 there, you can't. You got to leave that 2 alone, or maybe turn it into an 8 if you want. And there it is, because 2 to the 3rd is 8. Any questions? Because of this negative. Yeah, ask. Dime. Espinosa, you doing okay? Okay. All right, here we go. Find the slope, and we can do this without a calculator. Find the slope of the line tangent to the curve, y equals sine of the 5th x at the point where x equals pi over 3. They're not asking for tangent. They're just asking for the, that's it. So how do I find slope? Take a derivative. So remember, look, this is to the 5th power. Some of you are like, well, I don't know what to do with that. So until you turn beast, or maybe you're already beast. Maybe you're already beast. Until you turn beast, write it like this. Once you become a beast and you already know what you're doing, then you can just go right into it and go 5 sine of the 4th times cosine x, and you're done. But right now, we're not beast. Are we okay? Here we go. I'm taking a derivative. Y prime equals, what's my derivative? 5. Open parenthesis, leave the inside alone. To what power? 4th. Am I done? Times derivative of the inside. What's derivative of the inside? Cosine x. All right. Now comes pre-cal. You're done with calculus. Now comes pre-cal. It's not even extreme pre-cal. It's just baby pre-cal. So here we go. Y prime equals 5 sine of pi over 3. Close it to the 4th power. Cosine of pi over 3. How do we feel? Do you remember what sine of pi over 3 is? Good. Y prime equals 5 parentheses square root of 3 over 2, close it to the 4th power. What is cosine of pi over 3? 1/2. You can do this without a calculator. Here we go. I'm going to go slow. Here's my 5. Go square root of 3 raised to the 4th power. So square root of 3 times square root of 3 is 3. And then square root of 3 times another square root of 3 is another 3. And 3 times 3 is 9. 2 times 2 is 4. 4 times 2 is 8. And 8 times 2 is 16. And then I have this 1/2 here. So what's 5 times 9? So 45 over, and then 16 times 2 is? So the slope is 45 over 32. Maybe, but they didn't want you to use chain yet. They want you to expand with product or something. Because derivative 1 is just product and quotient. All right, here we go. I want the derivative of that. I'm going to go slow, guys. You do not have to do quotient rules. Matter of fact, I told you, if you have a constant in the top, or, don't use quotient. Here's what you're going to do. I'm just rewriting it. d dx, open parenthesis, open another parenthesis, 1 minus 2x, close it to the what power? Negative 3, close. I'm taking the derivative of that. I did record the yesterday's session after school. I'll upload it today to my YouTube channel. I'm going to put it on Canvas because that's not really a lesson or anything. So I'm just going to make it unlisted. It'll be on Canvas and I have paper notes if you want them. All right, here we go. You guys ready? All right. How do I take a derivative? I bring what to the front? Notice I already put an equal sign, so that means I'm taking the derivative of this, d dx of that. And then what do I do with the inside? Leave it what? Alone. What power? Negative 4. Times, am I done? Times what? Negative 2. Don't leave it like that. Do algebra. What is negative 3 times negative 2? That goes in the numerator. In the denominator, you have 1 minus 2x to the 4th. Are we okay? I don't see any issues there. I think we're good. Let's go to the next one, guys. Okay. So this is coming from your textbook, which you guys don't have, but if you would have checked out a textbook, it would have been on page 162. All right. Do you guys want to see if you guys can do this? Take like 2 minutes, a minute, and then we'll see if we got it correct. Maybe we'll even look at the College Board exam in a little bit, right, to see those questions. All right, try it out, miss. Try it out. This one's not extreme. What'd you get? Let's see. Y prime. What is the derivative of tan? So I write secant squared, leave the argument alone. Am I done? Times the derivative of 4x, which is 4. So my y prime is 4 secant squared of 4x. Yeah, good job, guys. All right, now let's see if you guys can do number 2. Number 2, guys. You guys close?
I'm getting like a really big equation.
Yeah, it's not be big. What'd you get?
Well, like, I don't know how to simplify it.
What do you mean?
It's like negative sine times cosine x.
So which one is it?
I don't even know where the 2 came from in most of these equations. It's not B, is it?
I don't know. I haven't done it.
Bruh. I'm just gonna wildly go to, I don't know.
What'd you get? Did you simplify it?
I don't know, but it's like that one looks like the most similar to this.
All right. First thing you do, if you're close to getting it, keep going. First thing you do, I'm going to move that 2, and I'm going to rewrite it. So here we go. Giant parenthesis, cosine x cubed plus x squared, close. I haven't done anything. Raised to the power 2, because that's what it means. That's what that square means.
That's not what I did. Oh yes, that's the edge.
That's what that square means, guys. Remember that from your algebra days or your pre-cal days. So here we go. Y prime. Am I gonna have enough space? I think I do. Y prime equals, what's my first derivative? Or what's my, when I first do it? Not that it is the first derivative of the whole thing, but what's my first step? 2. Leave the inside alone. To the power 1. Usually you don't write that in there, but we'll put it in there for now. Are we okay so far? Times the derivative of the inside. What's the derivative of cosine? Of x cubed plus x squared times, now I need to do the derivative of that inside. I'm talking about this one from the original. What's the derivative of x cubed plus x squared? Yes. All this is a product. All of them are a product. So let's see. I see a negative, so y prime equals a negative 2. And then I see that they put this factor in the front on all of them, so I'm going to put this in the front then. 3x squared plus 2x, close it. And then I'm just going to write the cosine of x cubed plus x squared. sine of x cubed plus x squared. And they could, if they wanted to, have used some identity, because I see like a possible double angle, half angle, double angle property being used that you could use. And there it is. So -2, 3x squared plus 2x cosine times sine. So it looks like it is C. Okay. How do we feel?
I did not like that.
Miss.
I feel like cosine.
You need to be miss. Come on. I mean, I guess if you do product rule, but you know you'll get the same. All right. Relax. We got a table. All we're doing is just rules. We're gonna see if we can do the rules. If we know all of our rules: product, quotient, chain, you name it. Y'all ready? All right. Suppose that the function f and g and the derivatives have the following values at 2 and 3. So you got f and you got g. So you got two functions and you got their derivatives as well. Evaluate the derivative with respect to x for the following combinations at the given values of x. Okay. So all it's telling you to do this. It's saying d dx of 2f of x at x equals 2. A line means evaluated at x equals 2. So this is a proper notation. So they want the derivative of that evaluated at x equals 2. So the derivative is just 2f of x. And then I'm going to put the value again, a little line like that, x equals 2. This is a proper notation. And why did I write f of x? F prime of x. 2f prime of x. Yeah, you got to catch me, guys. I didn't do that one on purpose. I just didn't put the prime. The derivative of 2f is 2f prime. Cool or not cool? Cool. So I'm just going to do 2f prime of 2 and then put the answer. So 2f prime of 2 is just 2 times, what's f prime of 2? 1/3. So my final answer is just 2/3. Yay or nay? Yay. That line means evaluated. It's math notation. It's I got it from computer science. Really, computer science got it from math. A line like that at the end of something, and then with an x equals some number or hashtag, that line means evaluated at. How many of you have taken computer science? So remember when you were coding and you did that little line and then x equals 3? Oh. How far advanced did you get in coding? Did you start doing like equations with programming? You just did like little loops, if then, if this, then this. Okay. Yeah, this is a big deal in programming. There's all like solving equations, because what's the whole point of programming? Like to make the computer do repetitive stuff fast. So this would be like a nested loop or something, or a loop. If then this, if you get this value, do this or whatever. All right, no big deal, miss. We'll do some more. We'll do. Okay, here we go. I'm not gonna do that whole thing again. Maybe you guys didn't like it. So the derivative of f of x plus g of x. So I'm just doing this. D dx is just f prime of x plus g prime of x. And all I'm gonna do is plug in a what? A 3. F prime of 3. What's f prime of 3? 2 pi. What's g prime of 3? 5. That's it. 2 pi plus 5. Done. Oh, man. I see a little rectangle. It should have been a dot. Okay. On letter C, for whatever reason, that should have been a dot. On letter C, it should have been a dot. I don't know why the formatting didn't come out properly. It's a dot like multiply. What rule do I use when I multiply? Yeah, I'm taking the derivative, so I got to use product rule. What's the product rule? First times derivative of the second. Second derivative of the first. If you do the delta math way, delta math does this second step first, and then does the first step second. It's the same thing. Because there's a plus in the middle, so it's the same thing. Are we okay? All right, here we go. I'm evaluating it at 3. So I'm doing f of 3 times g prime of 3 plus g of 3 times f prime of 3. F of 3 is 3. G prime of 3 is 5. G of 3 is -4. And then f prime of 3 is 2 pi. So my final answer is 15 minus 8 pi. Yeah, you can say plus a negative 8 pi. Cool or not cool? Okay. I'm going to change colors so they don't all blend in together. What rule do I got to use for letter D? Quotient. I'm taking the derivative, d dx. So what's my derivative of that? Bottom. Derivative of the top. Plus or minus? Minus. Top. Perfect. I'm going to go ahead and just start plugging in, guys. At x equals what? 2. So I'm going to put g of 2. What's g of 2? 2. F prime of 2. 1/3. F of 2. 8. G prime of 2. And all this is over 2 squared. So let's see. What is that number? I'm going to write it over here. So I see 2/3 minus plus 8, 16, 24 over 4. I'm going to turn that 24 into 24 times 3, 72. Common denominator. And then 72 plus 2. So 74, and I don't know why I switched it to red here. Sorry, guys. Let me go back to my color. 72 over 3. 74 over 3 times 4? 12. And that reduces. 37 over 6.
Oh, wait, because the 6 and 2 is 6 times 12.
So there it is. There's my reduced form. 37 over 6. I hope I didn't do any mistakes. I don't see any. Are you guys happy?
Yes.
Look at letter E. Finally, we're going into stuff that we learned today. What rule do I got to use for letter E? Chain rule. So I'm going to use black. So d dx of f of g of x is nothing more than f prime, leave rid of the outside, leave the inside alone, times rid of the inside. So here it is. I'm going to write f prime g of 2 times g prime of 2. I'm going to put the equal sign. I look for g of 2 first. What is g of 2? G of 2. Oh, they're being lame. F prime of 2. I wanted the number to be different. So now all I do is get f prime of 2, and I'm going to multiply it by g prime of 2. So f prime of 2 is f prime of 2. 1/3, yes. Thank you, Miss. I almost said the other one. 1/3, and then g prime of 2 is -3. So it looks like the output is -1. How do we feel? We're going to need chain rule again for letter F. Child, what do you mean? It's chain rule. This is what I mean. So I'm going to write it. I'm going to change colors so we don't get confused for what's what. D dx. And then this square root, I'm going to write it like this. Open parenthesis, f of x to the 1/2. So do you see how the f of x is in the inside now? Okay. So derivative of the outside, what do I put on the outside? 1/2. Open parenthesis, leave the inside alone. To the what power? -1/2 times derivative of the inside. So I'm going to simplify this. This is going to look like this. F of x over 2 square root of derivative. I said derivative of the inside, but I didn't write the prime. Sorry, guys. There you go. Now, Now it's correct. I said derivative of the outside, or derivative of the inside, but I didn't write the prime. I just wrote the inside. I don't see any errors. I think everything is perfect now. Let's see. Derivative of the outside, leave the inside alone, negative half times derivative of the inside, f prime of x. Okay. Everything looks good to me. I don't see any issues. So here we go. I'm going to put the little line because I want proper math. Evaluated at x equals 2 equals f prime of 2. F prime of 2 is f prime of 2, 1/3. So 1/3 over 2 square root of f of 2. And f of 2 was 8. Usually, on the AP exam, you can leave it like that. But usually you want to simplify it more, guys. The square root of 8 is 4 times 2. So here we go. I'm going to write equals. I still have that 1/3 on the top. Don't worry. We'll do something about that in a little bit. And then the square root of 4 is 2. And what's 2 times 2? 4. And I have a square root of 2. So you can just move that 4 square root of 2 up to that 3. Or keep change flip. 4 square root of 2 over 1. So 1 over 4 times 3 is 12 square root of 2. And that actually looks okay to me. Like, I'm okay with that. But most people rationalize it. So all that means is just put the radical on the top. So square root of 2 over 12 times 2 is 24. Whew, that was kind of tough. A little bit. But we're okay. All right. No, don't worry. Look how beautiful all this. You guys don't think that looks beautiful? Do you guys show this to your parents?
No.
Guys, or guardians, because I know not everyone has. All right. Kind of joking, but kind of serious. I really do want you guys to have, like, guys, your guardians and your parents, you're only going to be around for, well, hopefully they can be around forever. I want them to be. But, no, what I'm trying to say is this. You guys are about to leave on your adventures to college. Some of you guys are leaving out of state. You're only going to see your parents once or twice, maybe 3 times a year, guys. Yeah, right now. So do me a favor. Do all of us a favor. This is not just for me. This is just for all of our mental well-being. And everyone's alive right now. Everyone's healthy right now. So go talk to your guardians and parents. Have a conversation with them. Do something. Guys, we're among the living. This world is meant for the living. Go make memories. Go laugh. Go talk to your dad. Go talk to your mom. Go talk to your uncle. Go talk to your aunt. If you have good relationships, of course, with them. If they're weird or something, then I get it, I guess, All right. Here we go. Letter G. I'm taking the derivative. Are we using quotient rule?
No.
Heck no. Yeah, that's right. So here we go. I'm going to type it out. I'm going to write it out. Here's how you should write it out, guys. d dx, giant parenthesis. I'm taking the derivative with respect to x. That's what that means. And I'm going to write another giant parenthesis, but not as big. G of x, close to the power, -2, close giant parenthesis. Whole bunch of parentheses everywhere. Parentheses galore. Cool or not cool? All right, here we go. Derivative. So this is why I put more space here, because these require more. So the derivative. What's the derivative of that? -2. Leave the inside alone. So giant parenthesis. G of x, close to the what power? -3. And then I do what? Derivative of the inside times g prime of x. Let's make it pretty. So equals -2 g prime of x over giant parenthesis g of x close to the third power. You can put that 3 immediately after the g, but in case you're like, what I do with g, like, just do that. Cool or not cool? All right, here we go. Evaluated at x equals 3. So I'm going to look for, let me put that little line. Line evaluated at x equals 3 equals, so I'm going to look -2, and I'm going to look for g prime of 3. So go to the next page. G prime of 3. G prime of 3 is 5. Yeah. Yeah, it's still those. Over g of 3. What's g of 3? G of 3, -4. -4 to the third power. So -10 divided 12. I need a calculator for this. Negative 4 times negative 4 is 16, and 16 times negative 4, 16, 32, 64. Negative 64. So that reduces, negative divided by negative is a, so 5 over 32. How do we feel? Okay. Letter H. That one might take up the rest of the space here. This is a triple link chain. Chav, I don't see it. How is it a triple link? Let's rewrite it so you can see it. So I want d dx, giant parenthesis, another mid-sized parenthesis, and then another parenthesis, f of x close squared, plus giant or little g of x close squared, close to the power 1/2. Close. Oh, parentheses are your friends, miss.
These are like those things that like go outside and like
All right. Here we go. We're going to go slow. Sorry, I was reading the text about College Board representative. Okay. I'm not, yeah, you know what, you're right. Yeah. All right, here we go. Equals, bring the half down. We're doing chain rule. 1/2, leave the inside alone. So I guess for now, because this inside is going to be by itself, you can just write f squared of x plus g squared of x. Unless you don't like, oh, I can tell you guys don't like that. Okay, all right. I didn't even have to look at you guys. I could just feel it. That's crazy. All right, f of x squared plus g of x squared. Close it to what power? Negative 1/2. Am I done? No. Times the derivative of the inside. Open up a parenthesis, a big one. The derivative of that f of x with the square on it, you're going to have to do chain rule. So 2, open parenthesis. No. F of x. And now what do I put? Close a parenthesis. And on the outside of that I put? No. No. What? No. No. How many more no's? Guys, I'm doing chain rule with this guy. The f of x is now inside. So, no. 2, leave the inside alone. Power 1. No. Times. Times f prime of x.
Wait, what?
Chain rule. If I were to tell you, so I'm going to come up here with all this empty space. If I were to tell you, do d dx of f of x close squared, then you would tell me 2, empty parentheses, f of x times f prime of x, rid of the inside. And that's exactly what is happening right here. F of x to the power 2. I'm taking the derivative of that. So 2, leave the inside alone, f of x times derivative of that inside, f prime of x. Do we see that, guys? Okay. Yeah, it's okay. We're rookies. We're just getting started with chain rule. Now, we're making that mistake a year from now. Well, not a year from now. 9 months from now, right before the AP exam. Oh! Yeah, We'll be good by then. It's okay to make mistakes right now. You okay, Estrada? Okay. I would give you this water bottle, miss, but I already drank. I do have holy water. Power of Christ. All right. Sorry, miss. Sorry. All right. Here we go. Plus, we're gonna get this one. We're gonna get this one right now. What's the derivative of g of x raised to the power 2? 2 g of x. Yes. Close the parenthesis. Are we okay? Let's make it pretty. Chav, how do you make it pretty? Like this. You put some makeup on it and no, okay, that was stupid. I'm sorry, miss. I annoyed myself there. 2 f of x, f prime of x, plus 2 g of x, g prime of x. What happened to everything else, Chav? I'm bringing it down. Bring it down. I tried to do it. Yeah, you know what? I'm just going to teach math. Just teach math. Square root of f of x squared plus g of x squared. There's my derivative. What can I cancel to make life a little simpler for us? The 2's. Notice I can factor out a 2 in the top, and that 2 in the top will cancel with the 2 in the bottom. Do you guys see that? So can I just go? I'm going to evaluate this at x equals 2. So here's my answer. F of 2, I don't know, what's f of 2? All right, someone look at the front and give it to me. So Lavelle, you're going to be in charge. 8. Why did I change the color? Purple. 8. All right, what's f prime of 2? 1/3. Yes. Plus, what's g of 2? What is it? 2. What's g prime of 2? What is it? -3. All over square root. What's f of 2 again? F of 2, 8 squared plus, and then g of 2 was 2 squared, right? 2 plus 2. All right, let's see. We got 8/3. Let me write it better. 8/3 minus 6 over the square root of 68. We're okay so far? I haven't seen any mistakes yet. That 6, I'm going to turn it into 6 times 3, 6, 12, 18, 18 over 3. So then I get 8 minus 18, which is -10 over 3 square root of 68. You guys want to leave it like that? No? Okay.
Oh wait, I thought you were my bad. But then I think it looks pretty cute.
Okay.
I thought you had it as like -10 over 3 over square.
I don't see any initial mistakes. 1/2, -1/2, squared. Okay. How do we feel?
Good.
Okay. Well, how much time we still got? Okay. Take out your packets, guys. Yeah, I didn't know how much time we're going to have. The College Board packet from 2008.